transformations with this complicated math thing called group theory. And there's actually like a 300 level math class that you can take here about this. So I can't exactly explain exactly what it is to you, but it's basically a way of describing a set of numbers that has certain properties. So musical transformations are ways that you can take a series of notes and transform them, similar to the way in math. You've probably all done this in math class before. You can transform functions by flipping them over the x-axis, for example. So if you take that graph and just flip it over, it'll be the same but upside down. It'll be a reflection. If you do this in music, what you get is something called inversion. So here is, on the top, you can see a little part of the piece of music that Jennifer will be playing. And on the bottom is its inversion. So each time in the top, a note goes, the next note goes, okay. So this note here, you can see goes down from this note, but in the inversion it goes up the same amount instead. So that's what an inversion is. And you can also flip something over the y-axis. So if you take that half of that graph and flip it over like that, you will get that shape. And if you do this in the music, you get something called retrograde. So here is the original up to this point, and then it just flips around and plays backwards. And that's retrograde. So what I did was I combined these concepts with group theory. So instead of making a set of numbers, I made a set of musical transformations. And basically what this is showing is the 0 represents doing nothing to your music, just leaving it in its original form. The R represents doing a retrograde transformation, and the I represents doing an inversion. So if you combine any of these with any other part of that group, you can get back the same things that are in that group. So for example, if you combine a retrograde with nothing, then you get a retrograde, obviously. If you combine it with another retrograde, if you combine it with another retrograde, you get nothing. But if you combine it with nothing, you get a retrograde. And if you combine it with an inversion, you get what is a retrograde inversion. That's this. So you can get all kinds of different things out of this. And the reason this is a group, according to group theory, is because it has the properties of having inverses. In this case, each transformation is its own inverse. So if you perform retrograde on a retrograde, it's going to get back the original. That's what an inverse is. And it also has a like a 0, do nothing thing. So now Jennifer is going to come up and play the music that I wrote. I just made up a little random segment of music, and then what you're going to hear is the original, and then a retrograde, then a retrograde inversion, and then an inversion, and then the original again.